July, a month typically known for its beach days and hot weather, this year was known for overcast skies and rain. The greater Boston area experienced the second wettest July since record-taking began in the late 1800s. We had the chance to talk to Norwood resident and meteorologist at the National Weather Service, Boston, Joe Delacarpini, to talk about the science behind this historically rainy and unfortunate July.
Hi everyone, this is Joe Delacarpini. I'm a meteorologist and the Science and Operations Officer at the National Weather Service's Boston office, which is located in Norton. I'm also a Norwood resident and wanted to talk a little bit about our wet July, kind of what were the factors behind it. There were a couple of things that I'll describe today, but it certainly was a wet month here in the Norwood area, and we'll talk a little bit about that today. So first to start, just to look from a climate perspective, how wet was it? How extreme was it? We have to look at the records for Logan Airport over in Boston. That's our long-term climate site for eastern Massachusetts. And you can see some of the temperature data there as well, but we're going to focus in on the rainfall for July. You can see the average for the month of July is just over 3 inches, 3.27 inches. And in fact, the total was just over 10 inches, 10.07 for the month, and that's the second wettest July in the station's history. And the Boston records actually go back to the late 1800s. They've been at Logan Airport since about 1936, but prior to that, were located in various places in downtown Boston. So certainly kind of an historic amount there, being the second wettest since the late 1800s. And you can see the highest monthly total was back in 1921 at 11.69 inches. So fell short of that by about an inch and a half or so, but still pretty impressive for a July rainfall in Boston. Now here in Norwood, the airport officially had 9.79 inches of rain during the month, and I live over in the Tree Streets over by Highland Cemetery, and my rain gauge recorded 12.18 inches for the month. So, why the difference? Well, in the summertime, showers and thunderstorms can be pretty localized, and sometimes the heavier rain, even though it's raining across the whole area, the pockets of heavier rain will be fairly localized. So I'm about 2 miles west of the airport as the crow flies, so not unusual to see some differences like that in the summertime. So, really around the town of Norwood, about anywhere from about 9 to 12 inches on average, and compare that with the normal July rainfall, which is just over 3 inches, and you're talking 3 to 4 times the average amount. So that's certainly very impressive as well. So we're going to talk a little bit about the jet stream, which was one of the major reasons why we got stuck in that pattern of seeing showers and thunderstorms, pretty frequently throughout the month. So first, just a little description of what the jet stream is. There are bands of strong winds concentrated in a pretty narrow stream in the atmosphere, normally up in the higher levels, where the jets fly. So think of cruising altitude, 35, maybe even 40,000 feet. And there are 2 jet streams on each side of the equator, so in each hemisphere. We have the polar jet stream, which is typically more active in the winter and delivers a source of cold air. And then we have the subtropical jet stream. That's more dominant in the summertime months and provides warm and humid air. And occasionally in the wintertime, these 2 jets can kind of merge or come close together, and that's when we tend to get our big snowstorms. So the position, their orientation really varies day to day. It's almost like taking a jump rope and kind of flexing it up and down, and you see little bends and twists in it. But it does help us with general weather patterns. So is it going to be hot or cold, wet or dry? Those are general trends we can make out from looking at the jet stream patterns. So the important thing when we talk about the jet stream, we're identifying what are called troughs and ridges. So a trough here on the left is kind of a dip in the jet stream that you see here. Usually it allows colder air to come down from Canada, usually drier air too, but not always. And then we have the opposite known as a ridge, which is this kind of bump up in the jet stream here over the west. And this is usually warmer weather, sometimes more moisture as well. So again, in the wintertime, these are a little bit more evident than they are in the summertime, but still an important player in our weather during the summer months. So just to show a couple of examples before we actually show what happened in July, this was back in February of 2015. I think many people remember our 6-week winter blitz, which began in the end of January and lasted through most of February. There was what we happen to call a blocked jet stream pattern. So what does that mean? We have a deep trough here, which was over the eastern U.S. for much of that 6-week period. And at the same time, we had a very strong ridge just to the west off the Pacific coast. So Gulf of Alaska, those areas down to California. There was also another ridge parked a little farther off the east coast here. And it was those two ridges of high pressure that really caused this low to just get stuck where it is and kind of remain so. And as it stayed there, we had a series of low pressure systems. You can kind of see them identified here, rotating around that trough. And these were each of the winter storms we had. It seemed like every 3 to 5 days we had another foot of snow. And this is the reason why. Usually in the atmosphere, things move along. A trough like this might kind of sweep through in a day or two. But in this case, the atmosphere was what we call blocked and didn't allow this trough to kind of lift out and move off into the open Atlantic. So one example of a blocking pattern. A more recent one, and you may remember this from the news reports this past winter, was the snow and cold in Texas. Here's a look at the temperature difference over the middle of February, and you can see the blue shading representing colder than average temperature, and really was most notable across Texas, the southern plains, and even parts of the Gulf Coast. Well, again, we had a blocked jet stream. You can see here, this is the actual jet stream map from the middle of the month, and it comes in across the Pacific Northwest, dives down across Texas, and then lifts out across the eastern United States. So the center of the trough, you can see here that I'm using with my cursor, goes from the northern plains down into Texas. And again, we have what are called two ridges of high pressure. One is here off the west coast. It's just a little bit out of the picture. And the other is here off the east coast. Again, just a little bit out of the picture, but these two ridges of high pressure kind of blocked this trough from lifting out and caused cold Canadian air to come right down. Actually, it was from the Arctic, believe it or not, and came right down into the center of the country, causing unseasonably cold weather. Now let's go to July and kind of show what happened here. Now, I should note, in the summertime, the jet stream is weaker than it is in the wintertime, and that's because the temperature differences aren't as great. We don't have a source of Arctic air in the summertime. The atmosphere is a lot warmer. So there's less of a temperature difference, and that leads to overall a weaker jet stream. But you can still see here, this is at about 34,000 feet, showing where the jet stream normally is. You can see it comes onto the west coast, goes to the Canadian prairies here, and then dives down across the Great Lakes. You can actually see the trough here. It's centered over the kind of the eastern Great Lakes, and then lifts out across New England. So again, we've got the two blocking features that we talked about. One is a ridge of high pressure in the desert southwest. That's right here. And that was what led to the unseasonable heat throughout much of the western third of the country back in July. Temperatures were well above 100 degrees, even into the Pacific Northwest for a time. And then our other blocking high pressure is here off the East Coast. This is the Bermuda high, and in the summertime, it's quite prevalent just off the Carolinas, and that's what gives us our hot and humid days, especially. We saw some of them in June, but also we tend to see them more in July and August. So again, this trough here over the east was blocked. It really had nowhere to go and kept a flow of kind of warm and tropical air into the region. Winds come out of the south. You can see kind of the motion around the trough. These would be southerly winds here up the East Coast. And the air is coming right from the Gulf Coast, from the Bahamas. This is tropical air, and it was just repeatedly coming into the area for several days at a time. And the other thing that a trough does is it provides a source of lift. We need lift to generate showers and thunderstorms. And the eastern side of the trough, which is right over the northeast here, is a source of lift. So it gave us moisture and lift, which again helped cause those showers and thunderstorms. Now, it's also important to look at things near the ground, our surface map. We talk about highs and lows and fronts. This was a stationary front that really settled across the area for several days around the middle of the month and was a focus for showers and thunderstorms. So these fronts provide just a little lift, especially near the ground, and help get the air rising to generate clouds and showers and thunderstorms. So what happened was we had rounds of showers and thunderstorms developing in the eastern Great Lakes, say around Buffalo, traveled east along the front. That's what they normally do. So as long as this front didn't move, we were going to have repeated rounds of showers and thunderstorms. And that's certainly what happened, especially in the first 2 weeks of the month. So we had all the ingredients in place, a blocked kind of jet stream pattern that provided a source of moisture from the Bahamas, from the Gulf Coast. It also helped steer Tropical Storm Elsa up the East Coast as well. And then we had the stationary front toward the middle of the month, which provided the focus for repeated showers and thunderstorms across the area, most notably western and central Massachusetts and northern Connecticut. where they did have some flash flooding. Roads were eroded away, bridges washed out in some cases. Um, but really just a good pattern for heavy rain across much of the region back in July. So as we head into August here and September, we just want to remind folks that we are nearing the peak of the hurricane season. That's in about the middle of September. So always a good idea to keep track on the latest forecasts. We certainly do that for you at our office in Norton. You can go on the web, weather.gov/Boston, and find out all you need to know. But certainly keep tabs on the weather here as we come toward the end of the summer and look forward to the beginning of the school year in September. So again, I'm Joe Deli Carpini from the National Weather Service and a Norwood resident, and we'll talk to you soon. Thank you.